All right, so let's talk a little bit about why you can use inverse trig functions. So if I have something like the inverse tangent of the tangent of whatever it is, in this case, tangent of, I'll just call it x for now, because it could be theta or it could be whatever. Why does that end up resulting in x? And it does end up resulting in x. Well, it goes back to the days where we talked about composition of functions. When we said if we have two functions that are inverses, like f of x and f to the negative 1 of x, this guy's also known as the inverse function of f of x. We said, hey, if we take f of the inverse of x, we expect to get x as a result. In other words, this function and its inverse, it kind of cancels each other out, and all we're left with is whatever's in parentheses. Now, just to be clear about this, it's not always x that's the result, and we should be able to do this in two directions. We should also be able to take the inverse of f of x, and it should also pop x right out. Both of those should work just fine. And just to be really clear, I want to show you, if I have something like f of the inverse of a whole bunch of crazy stuff, like 3y minus 2, well, that is going to, if I take take the function of the inverse function of f of 3y minus 2, I'm simply going to get 3y minus 2 as the result. In other words, the function and its inverse sort of cancel each other. So that's why when we apply an inverse tangent to a tangent, all we get is what's inside, in this case x. If there was a number in there, that number would be here. If there was 3y minus 2 there, then that 3y minus 2 would be right there. And then also, if there's a theta there, then theta would be there. Now, it's important to realize that, again, when we apply this stuff, for instance, if I have something like, let's try sine, we'll actually take the inverse sine of the sine of theta, and we say that that is equal to the inverse sine of some ratio, whatever the ratio happens to be. We'll say that we were given that there was one side was the opposite side was 2 and the hypotenuse was 3. That's when we end up with theta equals inverse sine of negative 2 over 3. Now, some people, when they get the hang of this, what they do is when they see something like, let's go ahead and make sure you can see what I'm talking about. Some people, when they see something like sine of theta equals 5 over 7, they just immediately know to write theta equals inverse sine or arc sine of 5 over 7. If you get to the point where you're comfortable doing that, great. Otherwise, this is technically what's really happening. We're really taking the inverse sine of both sides, and it just so happens the inverse sine of the sine of theta gets us theta. And over here, we have to take the inverse sine if we did it over here. So, but this is another option. You see sine of theta equals 5/7, and you say to yourself, I'd like to know what theta is. So theta must be equal to the inverse sine of 5 over 7. Whatever works for you.